మీ బ్యాక్గ్రౌండ్ ఏంటి? ఫ్యాకల్టీ ఆఫ్ ఇంజనీరింగ్ అంటే ఎలక్ట్రానిక్స్ this is what's called a camera view of air station, some environments of the air station in Shadnagar. Okay. And it started in around late 1970s. Okay. At that time, the Andhra government, they gave this land of about 320 acres for acquisition of satellite data. And so at the time, it was again small steps, and later it is now enhanced with the dual frequency capable 8 antenna systems. Out of the 8, 7 for remote sensing and 1 for communication. These remote sensing antennas are mounted a few feet above, of the average of about 15 to 20 feet above the ground. What's called, if any building or anything, trees, etc., that should not disturb a line of sight between that antenna and the satellite's antenna. And many satellites, but again not all, they are equipped with the charge coupled devices. And it will be something like, for example, we keep some water in the fridge to make ice cube. Similar to that, it will look. It will be focused onto the earth. And during the daytime, if sunlight is reflected or near to that light, near to visible, it will be captured by the charge coupled device system, and immediately it will be converted into digital, that is analog to digital transformation. And immediately it will be, sometimes some satellites or many satellites, they will encode that. And that is numbers, for example, will change. And immediately it will be, it's called modulated with some RF carrier. If the data rate is very, very high, the modulation that carrier may be of some Ka band or an X band. Or if the data is somewhat lower, they will generally modulate with some S band carrier. And immediately after that, it will be transferred to the earth. And so it will be scanning the earth, something like a Xerox machine. And so these antennas are dual frequency capable, and depending on that frequency of the modulated RF carrier, they will use that antenna for the acquisition. And in order to acquire all that data, we require orbit calculations and related things, which are given by ISRO, one office of the Space Department in Bangalore. And about every 1-2 days in advance, they will transmit all the calculations to the Shadnagar people, who will what's called examine. Some of that is displayed in the form of like a timetable. Here there is a big screen in Shadnagar control room. We are seeing part of that. And green means there is a pass now in progress. And they are using AS2, AS6, AS2, for example. Now this antenna in the middle top is taking satellite data. And so it will follow that satellite's movement, and taking the data, and it will be subjected to certain processes. Just after reaching the antenna, it will be amplified with a low noise amplification. That already the satellite is a considerably large distance of several hundred kilometers. The signal will become very, very weak, and So what will happen? We should not add any noise, and at the same time we should accomplish our job. Okay. So it will be amplified with the low noise application. Immediately it will be reaching this control room by underground cable. Okay. And immediately after that it will be demodulated, and processes like frame synchronization, that is where the image is beginning and where it is ending, past where it is ending, all that it will be detected from that huge stream of the data what it is sending. Okay. And immediately it will be what's called put in a storage area network permanent memory establishment, which is very adjacent to the control room. Any satellite is passing over any part of India, we can take and to around Afghanistan. Okay. Even if it is passing over Pakistan, Afghanistan region, we can take, okay, and about 1/4 of China, okay, Tibet, all that we can take. Okay. And beyond that, it is not possible because of the earth curvature. Okay. So one way is the satellite will record that. For example, I've shown some Australia image, something like that. Okay. And when it is over India, it will transmit. Okay. That way is one way, or otherwise it can record and transmit to the polar region stations. That is, 2 stations are also there. One in Norway and another in Antarctica. And so these remote sensing satellites, because of their polar movement, whatever the data of any region it has taken, it will eventually pass above a pole. So if we establish a station to acquire the data in pole regions, it will be very, very beneficial. So accordingly, these are 2, one in North Pole and another near South Pole also have been set up. Okay. And some people will be taking the data there and giving to the, they will be giving to the office. Okay. And all these antennas are parabolic dishes. Okay. So this is one such model. Okay. And once the satellite, that is a few minutes before such a pass, for example, green. Okay. So another few minutes, about 5 to 6 minutes, I think, from now, it will be going on that pass. Okay. And it will be oriented. This antenna will be oriented to the direction, initial direction, as indicated by this track calculations. Okay. And there are 2 types of movements for this antenna. One is azimuth, that is horizontal circle. It can fully complete the circle, 360 degrees. And another in the elevation, okay, 180 degrees it can take. Okay. So it will be what's called adjusted to that direction. Okay. And then once the satellite sends that modulated signal, okay, some of the power will be striking this and it will going towards the focus, just like we put a magnifying glass under sun. Okay. And before that, it will be intercepted, before they reach the focus, it will be intercepted by a small hyperbolic plate, okay, which sometimes called a sub-reflector. Okay. And immediately it will reach this feed, okay, and it will be amplified inside this structure, okay, and it will go to the control room. Okay. That's how it will operate. Okay. And all this is because this antenna, this dish is very, very heavy. Okay. So it is an indirect way of collecting the data through this Cassegrain mechanism. It is operational.
There is basically science on sphere. It is made of carbon fiber. So we are using 4 projectors to project like any kind of data. It might be weather data, clouds data, or some other external data provided by NOVA and other teams. So basically this globe is divided into 4 quadrants, and each projector projects the video in each quadrant. So this is how this the entire video gets projected onto the globe.
Edges beyond Neptune. Our solar system is full of wonders. Giant storms, rings of dust and ice, rocky mountains, and even oceans hidden beneath frozen worlds. Each planet, each moon, and every asteroid has a story to tell. A story about how our cosmic neighborhood formed, evolved, and continues to change. So get ready to explore the planets, discover surprising facts, and see just how incredible our solar system really is. Comets, moons, and planets. The inner four planets closest to the Sun, Mercury, Venus, Earth, and Mars, are called terrestrial planets because of their rocky surfaces. The four outer worlds, Jupiter, Saturn, Uranus, and Neptune, are sometimes called the Jovian or Jupiter-like planets because of their enormous size. The main asteroid belt lies between the orbits of Mars and Jupiter. Pluto is a dwarf planet of the Kuiper belt of icy bodies beyond Neptune. It was reclassified from planet to a dwarf planet in 2006. Now let's know a little more about each planet. Mercury is the first and the smallest planet in our solar system. The planet's closeness to Sun makes its orbit shorter than those of any other planet. 1 year in Mercury is only about 88 Earth days. That is less than 3 months. Unlike many other planets which self-heal through natural geological processes, the surface of Mercury is covered in craters. Also, your weight on Mercury would only be 38% of your weight on the Earth. The second planet from the Sun is Venus. It is named after the Roman goddess of love and beauty, as it is the second brightest natural object in the night sky after the moon. It is hotter than Mercury, despite being further away from the Sun, because of the high concentration of carbon dioxide in its atmosphere. Venus rotates in the clockwise direction that is opposite to all other planets but Uranus. This means the Sun rises in the west and sets in the east at Venus. Then comes my favorite planet, the Earth, for obvious reasons. Earth, our home planet, got its name from a German word which simply means the ground. It is the third planet from the Sun at a distance of about 150 million kilometers. With a radius of 12,742 kilometers, it is the fifth largest planet in our solar system. It is a rocky planet with a solid and dynamic surface of mountains, canyons, plains, and more. Its atmosphere is 78% nitrogen, 21% oxygen, and 1% other ingredients, the perfect balance to breathe and live. It has one moon and no rings. It is the only planet known to support life due to availability of water and oxygen. About 71% of Earth's surface is covered by water, though less than 3% of all water is fresh water that is usable for drinking. And more than 2/3 of the fresh water is locked up in ice caps and glaciers, which leaves us with just 1/3 of the freshwater supply. It takes the Earth 23,934 hours to complete a rotation on its axis and 365.26 days to complete an orbit around the Sun. The next planet is Mars, also known as the red planet, since it is red in color, which comes from the iron oxide or rust present in its rock and soil. It is the second smallest planet in the solar system after Mercury, with a diameter of 6,791 kilometers. It is roughly half the size of the Earth. Mars is home to the highest mountain in our solar system, a volcano called Olympus Mons. It has 2 moons, Phobos and Deimos. It takes a lot longer than Earth to complete its orbit around the Sun, resulting in a longer year at Mars, lasting 687 Earth days. Jupiter is the 5th planet from the Sun and the biggest planet of our solar system. Both Jupiter and Saturn are termed as gas giants since they are made of
Here we go. Take off in 3, 2, 1. Are you still with me? We're now 300 meters above sea level and climbing. Have a look around. It might not look like the place you consider home, but give it another minute. You're now 100 kilometers above sea level and officially in space. Let's find a good place to stop. Take a deep breath and look at where you've come from. Do you recognize it now? You can no longer see the lake, the beautiful trees, or the green grass. But now you see why it's all part of the place that is our home. This amazing planet we all share. Looking at the Earth from space made me realize the interconnectedness between everything and everyone on that tiny, fragile and precious blue dot. I realized that despite our differences, we are all in the same boat or spaceship. I felt a sense of responsibility towards our home, to the life and lives it supports. This feeling has stayed with me ever since. Among astronauts like me, we call this feeling the overview effect. Just take a moment to let it all sink in before you start your journey back home. Look at the northern lights and the galaxy behind. And do you see that thin blue line surrounding our incredible planet? That's the atmosphere. And it has sustained all life on Earth for millions of years. Earth is an extraordinary place. But lately, our way of life has become a threat to the very home we depend on. We have upset the balance within our environment and caused the climate to change. We need to take responsibility, not just for causing it, but for fixing it. Because it's not enough just to love our home. We need action. Let's go back.
Satellite visibility time. Like you can see, like Meteor M24 is next visible at 1330 at 0 degree elevation. So the peak elevation is around 11.1 degrees. So basically, this is the elevation and this is the azimuth from 0 to 180 degrees and elevation from 0 to 90 degrees. So this is the this is the NRSC ORF center. So you can, the trajectory of the satellite is also displayed whenever the satellite comes into the visibility region, that is displayed. And we are using one more software, SatDumper, for receiving the data and processing and finally displaying the image. The image looks similar to that. That is the weather data of Meteor M2 satellite, clouds data. This is the antenna setup.
How much slot range you require?
How much?
Slot range. Slot range.
Range in the sense azimuth and elevation you are talking about. Generally, like here you can see the elevation is 0 degrees at 1330. At 1335 peak elevation is reached at 11 degrees. Yeah, and at 1341 it get decreased to 0 degrees. It moves from here to here or here to here. You can depending on that. This is the antenna setup over the terrace. This is a VHF UHF antenna. So through a coaxial cable, the data is taken into this room, and from there it is connected to a software-defined radio, where it gets down converted, demodulated, and digitized, and finally given to the system. And in the system, the processing happens, and finally the image is displayed like this. And one more thing is that we are having a global navigation satellite receiver also, from which there are many global satellite navigation systems, constellation of satellites. Like GPS belongs to US, Galileo belongs to the European Space Agency, GLONASS is launched by Russia, Baidu by China, QZSS by Japan, and India is also having regional navigation satellite system called NAVIC or IRNSS. Initially it was planned for a constellation of 7 satellites for covering India and 1500 kilometers surrounding India. Currently 6 satellites you can see here. 6 satellites are visible, and here GPS, Galileo, GLONASS, all the satellites are visible here. These are the latitudes of the satellites.
Guiding of frequency, what are the amplifiers are using?
What's it?
What are the amplifiers are using?
Onboard. Onboard generally solid state power amplifiers or TWT, traveling wave tube amplifiers should be used. We set up a global navigation satellite receiver in our ground station. So you can see, so these are the many global satellite systems are there, constellations. Like for example, GPS is launched by US, GLONASS belongs to Russia, Galileo belongs to ESA, and similarly India is also having its own regional navigation satellite called NAVIC or IRNSS. This is basically to cover India and 1500 kilometers across India. Initially it was planned for 7 NAVIC satellites, but currently 6 are available as seen in the screen.